Hello there. So finally, we're taking all the pieces we've built and forging them into a single unified trading bot script. All right, so Gemini is doing its job and tries to consolidate everything. Before we dive into the code itself, it's giving us a quick pre-flight checklist, which is super important. First, API keys. It's reminding us to make sure our Alpaca keys are set up, preferably as environment variables for security. We don't want to accidentally leak our secret keys. But as you probably remember, we can regenerate them for our paper trading account if we want, so that's cool. Next, dependencies. This is just a list of all the Python libraries our bot needs to run, like Alpaca Trade API, XGBoost, and Finta. A quick pip install, and we're good to go. It also notes that the script is designed so key things like our API connection and the trained model are accessible everywhere they need to be. And, of course, the golden rule. Always test in paper trading first. Okay, checklist complete, and we can get to the code. Just a quick reminder, remember that this is not a financial advice. As usual, we are using a paper trading account with no real money. We are just having fun, creating the bot, and if you would like to use it, you should make it much better because for now, as we've seen before, the bot is mostly losing money, but it's a good starting point. So, not a financial advice, just a tutorial for creating the bot with help of Gemini. And that being said, let's move on to the code.
Okay, so here we start with the classic opening act of any Python script, the imports. We're pulling in everything we need. OS for our environment variables, alpaca_trade_API to talk to Alpaca, pandas and NumPy for data handling, datetime for time, and traceback, which is a lifesaver for getting detailed error messages. Then we have our special guests, Finta for all those technical indicators, the Scikit-learn and XGBoost libraries for our machine learning magic, and matplotlib for that cool backtesting chart.
Cool. Now that we have it, this next section is our bot's brain, all the settings that control its behavior. First, the API setup. You can see it's set to the paper trading URL, and this is where you'd paste your keys if you're not using environment variables. Then we have our trading parameters. Remember the order symbol versus position symbol issue? We defined both here, BTC USD for trading and BTC USD for checking our portfolio. We're telling the bot to trade $100 at a time, but if you want to use more paper trading money, you can change it here. And we've set our confidence threshold to 55%. This means the bot will only buy if the model is at least 55% sure the price will go up. And finally, our safety net, a 1% stop loss. Below that, we're just telling the bot how much historical data to use for training, 30 days, and what we're trying to predict, the price 5 minutes into the future. Nice. Now we're setting up a few global variables here, API and model, which will be populated later. It's a simple way to make them accessible throughout the script. And here's our first function, initialize Alpaca API. It's a clean little function that reads our keys, tries to connect to Alpaca, and prints our account status. If it fails, it tells us why and stops, which is exactly what you want. No connection, no bot. Next up, data. This function is a beast. Its job is to grab all the historical price data we need for training. Since Alpaca has limits on how much data you can get in one go, Gemini has built a clever loop here. It fetches data in chunks, pieces them all together, removes any duplicates, and makes sure it's all in perfect chronological order. Super robust.
And this is where the AI part really starts. The create features function takes our raw price data and engineers all those technical indicators we talked about. SMAs, EMAs, RSI, MACD, Bollinger Bands, you name it. It also calculates lagged returns. This turns our simple price chart into a rich data set that the model can actually learn from. Notice it also handles cases where some data might be missing, which prevents crashes.
With our features ready, it's time to train the model. This function does a few critical things. First, it creates our target variable. It looks 5 minutes into the future and labels each row as 1 if the price went up and 0 if it didn't. This is what we're teaching the model to predict. Then it splits our data into a training set and a testing set. It trains the XGBoost model on the first part and then uses the second part to see how well it learned. We get a nice little classification report to check its accuracy. And look at that. It even prints out the most important features. This tells us what indicators the model is paying the most attention to. Okay, so before we go live, we need to see how our strategy would have performed on past data. That's what this backtester does. It takes the test data, pretends to trade based on our model's predictions, and tracks a fake portfolio. It even accounts for transaction fees. At the end, it prints the total return and, thanks to matplotlib, gives us a nice chart of our portfolio's value over time. It's a crucial reality check. Okay, now we're shifting from the past to the present. This function is the live version of create features. When the bot is running, it calls this function to get the most recent market data and calculate the exact same set of features our model was trained on. This is critical. The live data has to look exactly like the training data for the model to make a good prediction. And here it is, the main event. The check and place trade function is the heart of our live bot. Let's walk through it. First, it calls get live features to get the latest data. Then it feeds that into our trained model to get a prediction and a confidence score. Next, we have that super resilient price fetching logic. It tries to get the price from the snapshot first. If that fails, it has a backup, get latest crypto trade. And if even that fails, it has an ultimate fallback to just get the close price of the last bar. This makes our bot much less likely to fail because of a small API hiccup. Finally, the trade logic itself. If the signal is 1, for up, and the confidence is above our 55% threshold, it checks if we already have a position. If not, it calculates the buy quantity, figures out the stop-loss price, and submits the buy order with the stop-loss attached all in one go. Perfect. If the signal is 0 for not up, it checks if we do have a position. If so, it first cancels any protective stop-loss orders and then submits a market order to sell everything. Clean and simple.
And now the main execution orchestration. This is the conductor of our orchestra. When we run the Python script, this is the code that actually executes. You can see the sequence. It calls initialize Alpaca API. If that's successful, it fetches the historical data. It creates features and trains the model. It runs the optional backtest so we can see the results. And finally, if a model was successfully trained, it kicks off the live trading loop. Look at this loop here. It's set to run 5 times for this demonstration, waiting for the start of the next minute between each check. For a real 24/7 deployment, you'd just change this to a while true loop. And that's it. Every single piece, from data fetching to model training to live trading, all neatly organized into one script. We are ready for deployment.
Okay, so let me copy and paste it into our notebook. And let's check the final thoughts from Gemini about key sections and flow. So Gemini is giving us a quick bird's eye view of the entire script. It's basically a step-by-step summary of our bot's logic. It starts with the setup, imports, and constants, then it moves into the training phase. It connects to Alpaca, fetches historical data, creates features, trains our XGBoost model, and runs that quick backtest to see how we did. Next, it highlights the live trading functions. Get live features grabs the latest data, and check in place trade is the core function that makes predictions and executes orders with our stop-loss safety net. Finally, it points out the if-then-main block at the bottom, which is the part that runs the whole show in order, kicking off the trading loop only if the model was trained successfully. And here's the launch sequence Gemini gives us. We just save this as a Python file, make sure our API keys are set, and run it from the terminal. Then we just monitor the output and watch our paper trading account to see the bot in action. Simple as that. So yeah, that's what we'll do now and see if it actually works. Fingers crossed.
First, let's replace our API keys.
And now, do you think it'll work?
So far, so good.
And no, we got an error. That's a bummer. So Gemini, what do you have to say on that? Give us a quick fix and let's make the magic happen. Let's finish this bot and make it usable. One less fix, please. Thanks. So yeah, according to Gemini, the error appeared because our model's predictions are returned as a different data type, a NumPy array, which doesn't have the .empty attribute we were trying to use. The fix is simply to use the correct check for a NumPy array, which is .size equals 0. So let me do it, and let's run the bot once again.
All right, take 2. And we are live. The script is running, the log is scrolling, and most importantly, no red error text. That's what we love to see. So the bot is now officially on its own, monitoring the market every minute. Now comes the exciting part. We wait and watch for the first buy or sell signal to see how it performs in the wild.
And we are live. The bot is running, and you can see the logs ticking by every minute. Now, a crucial part of algorithmic trading is what's happening right now. Active, disciplined waiting. The bot isn't firing off trades left and right. It's analyzing the market and holding off until our model gives a signal with enough confidence. I used this time to do a little code side chat with Gemini. I wanted to use its intelligence to help us learn more about our own creation. After all, the goal isn't just to have a bot, but to understand it. You can see Gemini's full answers on my website if you want to dive deep. But essentially, I asked 2 main things. First, what does this log output actually mean? Gemini confirmed that the bot is successfully running its entire pipeline from fetching data to making a prediction, and that its decision to not trade was the correct one based on the model's output. And second, how does our AI model actually calculate its predictions? And this is fascinating. Gemini explained that our XGBoost model is like a committee of hundreds of simple decision makers, all working together and learning from each other's mistakes to spot complex patterns in our features, patterns that tell it whether the price is likely to go up or down. So, thanks Gemini for explaining that. I'm sure I'll have more questions in the future. And now let's wait and see if and when we see any real action here. Okay, so the bot is live, the code is running, but as any experienced developer knows, the real test begins when your code meets the chaos of the real world. I let the bot run, and after some testing, I pulled the activity logs from my Alpaca paper account, and that's when we discovered the truth. The bot thought it was working, it placed the buy order perfectly, but our safety net, the stop loss, was never created. The bot was trading unprotected. This is the most dangerous kind of bug, a silent failure, and it's exactly the kind of thing we need to learn how to hunt down. So I took this problem back to Gemini, and this kicked off what I think is the most critical lesson in this whole series, the journey from a simple script to a robust, resilient trading system. Our investigation went through several key stages. First, we discovered the race condition. The market order we were using was the culprit. It would fill at one price, but by the time the stop loss was placed, conditions had changed, and the exchange would reject it. Our first fix was to switch to a limit order to make the entry and protection a single atomic unit. But that led to a new discovery, API rules. The Alpaca API told us that to attach a stop loss like that, we needed a full bracket order, which also requires a take profit target. This was a dead end for our strategy, but it taught us to read the error messages carefully. Digging into Alpaca's documentation, we found the real tool for the job, an OTO, or one triggers other order. It's designed for exactly what we want, an entry that triggers a single stop loss. Perfect. This error was a revelation. It turns out Alpaca's crypto API doesn't support these advanced order types. This is a crucial real-world lesson. Your code can be perfect, but you are always bound by the specific rules of the platform you're trading on. So this forced us to build the logic ourselves. The only path forward was a manual two-step process. First, submit the market order to guarantee entry, then immediately pull the API to confirm the fill, and then submit a separate stop limit order to protect the new position. This process uncovered the final bugs, like accounting for fees by using the actual filled quantity from our portfolio, not our calculated one, and building a state-aware sell signal that proactively cancels old orders. After all that, we arrived at the final, robust code. It's not just a script anymore. It's a system that's been battle-hardened against the realities of a live trading environment. And now, let me show you how this version works. So, in this cell, I have the final bot code. I've hard-coded an extremely tight stop loss of 0.0001% and forced a buy signal specifically so we can see the full, correct trade lifecycle in action. And here we go.
At the moment, our portfolio is empty, so we can run the bot and check step by step what's going to happen. And like previously, the bot starts with preparing data, training and evaluating the model, backtesting, and finally, we start live paper trading. We can see the features, but we hard-coded the buy signal, so they are not that important here. And we can see our buy signal. We see the bot checking the order was filled, checking the amount of Bitcoins it has in portfolio after fees, and we can see that we place the stop limit order for that quantity. And there it is. Success. Position is now protected. That's the confirmation we've been working towards this whole time. So the bot's job is done for this minute, but the market's job is just beginning. Now we wait and see if the price action actually triggers our new robust stop loss.
And yes, it did. And it happened really fast because our stop loss price was pretty much the same as the price for which we bought our Bitcoins. Again, it's set like this to check if it works. So let's wait a moment and see what happens in the next minute. And now we can see the notice from our bot that the stop limit order was executed. Thanks to this, we can follow what's happening. Let's wait a little longer and see one more cycle like this. And there it is. Now we can say that it works.
So there we have it, a complete success. I want to say a huge thank you to Gemini for guiding me through this entire process. The journey we just took from a simple script to a battle-hardened system is the true story of building a trading bot. It's about hitting walls, diagnosing problems, and systematically building resilient solutions. We didn't just fix bugs, we learned how to think about state management, API limitations, and creating a bot that can recover from the unexpected. And now, with our hard-coded test settings removed, we can finally look at the finished product. Is it perfect? No. The AI model itself still needs a lot of work to become consistently profitable. But what we have created is the essential, rock-solid foundation. We have built the reliable car. Now the challenge is to teach it how to drive better. The core logic is here, and it works. Oh, and before you use this bot, remember to replace the API keys. Now, I've posted the complete final code from this video on my website, so you can find it in the 8th part of our series. And if you need to generate a new set of API keys, you can do that right from your dashboard on the Alpaca website. And I think that's all for me for this video and for this series. In future tutorials, we'll explore ways to improve this bot. For example, we could change the machine learning algorithm or do the tweaking Gemini told us about, like searching for the right hyperparameters and modifying the target. But for now, you have a bot that you can run with one click and customize as you see fit. And when you do try to change it, a good tip is to give Gemini the link to the code so it knows what you're talking about. I hope you liked this series and learned something new. I definitely did. I loved doing this tutorial and learned so much about working with Gemini. The journey was sometimes fun, sometimes tiresome, especially the bug fixing part, but I find the outcome really fulfilling. Anyway, all that's left for me is to say thank you for watching. As always, I wish you all the best, and remember, improve yourself, improve your business, improve the world, but also live and have fun, because that's really important. Thanks, and hopefully I'll see you in the next video. Yours, Super AI.